define EMF of cell. EMF is electromotive force of cell. The amount of work done to move unit positive charge in complete circuit once is called as EMF of cell. It is given by E equals to W upon Q, or you can say dW upon dQ. Its SI unit is joule upon coulomb or volts. Right, definition of EMF of cell. Completed till end?
Yes.
Obtain the condition when E greater than V, E equal to V, E less than V. That means EMF is greater than terminal voltage, equal to terminal voltage, or less than terminal voltage. Case 1. Hello? हाँ मैडम, हाँ मॉर्निंग मैडम, हाँ हाँ चलेगा चलेगा, मैं प्रीतम सर से बात करूंगा। और नेक्स्ट मंथ से मैडम आएंगे फिजिकली, एक बार थोड़ा चालू हो जाने दो। हेलो मैडम, नेक्स्ट मंथ से ना आई विल ट्राई टू कम, डोंट वरी। ओके ओके, नहीं नहीं, उससे उससे बेनिफिट होता है, और क्या वो क्या कर रहा है वो भी समझेगा। तो मोमेंट थोड़ा सा रिलीज हो ना, डेफिनेटली आई विल कम। यस 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 यस, थैंक यू मैडम, थैंक यू, बाय बाय। हेलो, हाँ, when a battery of EMF E internal resistance small r is connected across external resistance capital R to supply current I. Consider a battery of EMF E, internal resistance R, connected across resistance capital R to supply current I. V be the potential difference. Then can I say total EMF is utilized for external voltage plus internal terminal voltage? Again, see, consider a battery of EMF E, comma, internal resistance R to be connected across resistance capital R. So total EMF is used to send the charge through this external plus internal. Hello?
Yes, sir.
So I can say EMF is terminal voltage across resistance plus internal voltage. This line you followed? मतलब ये बैटरी इसको ओवरकम करने के लिए वोल्टेज देगा, इसका भी ओवरकम करने के लिए वोल्टेज देगा. तो E is V plus V. Have you understood this line, Vatsal?
Yes, sir.
Total voltage of the battery is consumed by whom? External plus internal? Not understood. What is law of conservation of energy? Energy can neither be created nor be destroyed. EMF is work done to move the charge in complete circuit. Terminal voltage is work done W dash to move the charge Q in external, and small v is work done to move the charge in internal. Work means energy. So work will be EQ total, which is VQ plus V into small q. I can cancel this. So can I say total voltage is used for external plus internal?
Yes, sir.
Once you have followed this,
Yes, sir.
one line. So when battery is supplying voltage to the resistance, then resistance बाहर वाला plus अंदर वाला दोनों मिलके voltage खाएंगे. So you can say E equals to V plus I into small r. Now E is V plus IR. तो E V से बड़ा है क्या नहीं? Hello?
Yes, sir.
Yes, sir.
E is greater than V. So we got this condition. Also, E, V means I into capital R plus I into small r. So E is I into capital R plus small r. Therefore, I is E upon capital R plus small r. When this current will be maximum? This I, when it will be maximum?
When there is resistance.
When resistance denominator is minimum. So ये R0 चाहिए ना, इसको तो जो है वो है, तो internal resistance should be minimum. So I can say 2 points here. EMF is greater than terminal voltage. Terminal voltage मतलब ये resistance के across का voltage when it is supplying the current. So first you all copy this, then I'm explaining further. Any doubt? Please ask. Any doubt in this?
No, sir.
Write down. Very simple it is. Yes, completed writing.
Yes, sir.
Thus, maximum current that can be drawn मतलब pulled or taken out from the EMF device. EMF device means battery, is when capital R becomes 0. So I maximum is always battery का EMF upon R. See books में ऐसा दिया है epsilon sign, but to make it easier I am writing E. Both are same. E by R. Write this. Maximum current is E by R. Hello? हाँ. अरे बुक पे लिखा है बोलना, नहीं तो वो बुक रिटर्न दे दो उसको. वो बुक पे लिखा है 240 काय के लिए लिखा है, एड़ा बना रहा है क्या अपने को? वो उसका फोन दो उसको अगर वो है तो. हाँ दो. हेलो. हेलो. Yes, completed. Completed ना?
Yes, sir.
Case 2. That means condition when E is greater than, E is less than V, equal to V. When battery supplies current, then E is V plus IR. Thus, if R is 0, then can I say E is equal to V? Hello?
Yes, sir.
Yes, sir.
Also, if I is 0, then E equal to V. Two condition we got. I 0 means battery is not supplying current. Thus, when battery is not connected to external resistance or internal, or if internal resistance is 0, then EMF equals to terminal potential difference. Now for people, case 2. हाँ नहीं मैं दिया क्या उनको. तो अभी तो आप बोल रहे हो कि हाँ अभी जाने वाले हैं उधर। हाँ तो हाँ बराबर है ना, वो क्लियर 240 लिखा है तो अपन पागल है कि उसको 300 देंगे जूना बुक का। हाँ बिल दो और वो फोटो भी दिखाओ उसको, और उसको ना नहीं चाहिए तो अपना बुक रिटर्न ले लो आप। हाँ तो ठीक है, ये बुक पहले उसका इसका निपटाओ। नहीं नहीं इसका निपटाओ, उसको क्या लगता है कि अपन पहली बार बुक खरीद रहे हैं क्या? और आपको भी नहीं मालूम है क्या बुक के ऊपर लिखा रहता है वही रेट होता है ना, पीछे वाला रेट थोड़ी होता है रेट। अरे ऐसा नहीं यार, अपना मेहनत का पैसा है, उसको ऐसे ही दे देंगे क्या अपन? ठीक है। Once you complete, please tell her. Then third condition. Then last topic, cells in series in parallel concept. Okay, done na?
Yes, sir.
When battery does not supplies current, then this condition is also called as open circuit. That means when battery is not supplying current, sometimes they can also say open circuit. Case 3. Condition for E less than V. So if this is battery with internal resistance R, I have to charge this battery as we do in mobile. Then we connect to the external source. So this is charger, suppose, whose resistance is R. Charger has variable resistance. And voltage between 2 point is V. This time battery is not supplying, charger is supplying. So bahar wala is giving to battery or battery is giving to bahar wala voltage?
Bharwala is giving to battery.
So can I say in this case, bahar wala voltage will give voltage to the battery plus to its internal resistance?
Yes.
Yes, sir.
So this will be E plus I into R. Now what you can say, V is greater than E or not?
Yes, sir.
That means E is less than V.
Yes.
Yes.
So when battery is supplying, then E greater, battery is taking, then E less, neither giving nor taking, both are same. Copy, draw the diagram and write third case.
Done, sir.
Conclusion will write. When battery supplies current, then E equals to V plus I into R. When battery draws current, then V equals to E plus IR. Therefore, E is V minus IR. V minus IR. Third, for open circuit, that is battery neither supplies nor draws current, neither supplies nor draws current, then E equal to first, second, third point, right? Then last two topics, cells in series parallel condition we'll see.
Done, sir.
Next reading, cells in series. Series means one after another. When cells are connected in single electrical path, that means in same straight line, single electrical path, then they are called in series. If E1, E2, En are n cells in series as shown, then as shown. That means this is E1, R1, negative is connected to positive, E2, R2 dot 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 up to En, Rn. Then resultant EMF E is E1 plus E2 dot 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 up to En. When cells are connected in single electrical path, they are called in series. If E1, En are n cells in series as shown, then resultant is E1 plus E2 up to En. Copy. The equivalent hello हाँ हाँ, हेलो हाँ सर जी वो बुक तो ये सेकंड हैंड लिखा भी है 240 ऊपर प्राइस सेलिंग प्राइस नहीं नहीं फिर वो रिटर्न ले लो बुक यार मैं पहली बार बुक थोड़ी ले रहा हूँ यार 2019 से 2010 का पेपर है 300 उसका बुक प्राइस है 240 उसका सेलिंग प्राइस लिखा हुआ है नहीं नहीं मैं वो बुक रिटर्न कर देता हूँ मैं दूसरी जगह से ले लूंगा अरे पहली बार थोड़ी मैं बुक ले रहा हूँ हाँ मैं बुक रिटर्न दे देता हूँ ठीक है ओके हाँ संतोष दे देता हूँ उनको बुक रिटर्न the equivalent internal resistance R will be R1 plus R2 up to Rn. Written? Yes, completed till there?
Yes, sir.
Yes, sir.
Now just same thing. Be careful. Look on the screen what I have drawn. Now this way I'm connecting the cells. Positive, negative. This is connected to negative, positive. Now see, these cells are connected in same single path because there is no division. Hello?
Yes, sir.
But this will send current in left and this will send current in right from positive.
Yes, sir.
These two current are in same direction or in opposite direction.
Opposite.
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 So whenever cells are in series but like terminals are connected together, then we say they oppose each other. When cells are in series but like terminals are connected together, that means minus minus plus plus, but like terminals are connected together, then resultant EMF is not sum, is difference. That means E will be E1 minus E2 if E1 is greater than E2. So when cells are in series, not necessarily every time it will be plus. Only when plus minus plus minus plus minus are connected together, then sum. If of like plates terminal together, then difference. And equivalent resistance will remain sum. It will not. Have you followed this meaning? When
Yes,
to add?
sir.
Okay, please write. Very important. Sometimes they will give this type of case in series. So not necessarily every time voltage will be sum. If it is of similar terminals joined together, it can be difference also. Done?
Yes, sir.
Then write advantages of cells in series. Advantages of cells in series. First, the resultant voltage increases. The resultant voltage increases. Second, cells which are damaged can be easily identified. Hence, can be replaced easily. Can be replaced easily. Can I clear now? Okay. Derive expression for equivalent EMF and internal resistances when two cells are in parallel. This can be asked in college exam. Derive expression for equivalent EMF and internal resistance and equivalent internal resistance when cells are in parallel. Copy the heading, then I'm drawing the diagram to give you the explanation. Draw this diagram also. We are interested in equivalent EMF of these two batteries and equivalent internal resistance. Chalo, can I clear this circuit?
Yes, sir.
First cell is giving the current I1 or taking the current I1? First cell. It is giving the current I1 or taking the current I1?
Giving the current.
Giving. So from positive it is starting, therefore it is called giving. Same way second wala is also giving.
Yes, sir.
Okay. So if I look at first cell, it was like this, see. Battery, internal resistance connected between these 2 points A and B. So if this is E1, this is R1, supplying current I1, what is potential difference across this end? Can I say it is E minus I1 R1 will be the remaining voltage?
Yes, sir.
So for first cell, the potential difference between point A and B is E1 minus I1 R1. Potential difference we can call as V equals to E1 minus I1 R1. Therefore, I1 R1 will be E1 minus V. So I1 is E1 minus V upon R1. Any doubt in first equation?
No, sir.
Similarly, we can say I2 will be E2 minus V upon R2. But total current I is I1 plus I2 because at junction A, I1, I2 both are meeting. So we add this. I1 plus I2 will together become I. Copy till this much, then I'm explaining further. Atharva? Atharva Raut? Hello, Raut.
Sorry, sir, I got disconnected due to low internet issue.
Acha, acha. See, I'm recording and then thing goes wrong. You can see, don't worry.
Thank you, sir.
Okay. Completed? Completed till end? I equals
Yes,
to?
sir.
So I can say therefore I equals to E1 R1 minus V1 upon R1 plus E2 upon R2 minus V upon R1 V upon R2. So I will become E1 upon R1 plus E2 upon R2 minus common V upon R1 plus V upon R2. Hello? Now this term, if I bring on left hand side and I take on right hand side, then it will become V upon R1 plus P upon R2 will be E1 upon R1 plus E2 upon R2 minus I. So from this V common, 1 upon R1 plus 1 upon R2 is E1 upon R1 plus E2 upon R2 minus I. So V becomes E1 upon R1 plus E2 upon R2 minus I divided by R1 plus R1 upon R1 plus 1 upon R2, 1 upon R1 plus 1 upon R2. Any doubt till this what I did?
No, sir.
See, I've just separated out V. Now, if you see this carefully, hello?
Yes, sir.
So from this we can say V equals to E1 R2 plus E1 R1 E2 R1 upon R1 R2. Here also LCM, this will be R2 plus R1 upon R1 R2. This will get cancelled. Minus I upon R2 plus R1 upon R1 R2. So V equals to E1 R2 plus E2 R1 upon R1 plus R2 minus I R1 R2 upon R1 plus R2. Please copy till this. Then one line we have to compare with battery supplying current wala formula. It appears to be difficult, but not at all difficult. If you go on writing, you'll get the answer properly. Yes, completed till end.
Yes, sir.
Yes, sir. Complete.
Okay. Okay. Therefore, comparing with V equals to E equivalent minus R equivalent, we get E equivalent equals to E1 R2 plus E2 R1 upon R1 plus R2. Correct now? And R equivalent is R1 R2 upon R1 plus R2. Hello?
Yes, sir.
That is E equivalent. Okay, चलो इतना लिखो पहला. So we got E equivalent, we got R equivalent. Then I divided E equivalent with R equivalent. That is giving answer E1 R2 plus E2 R1 upon R1 into R2. Now I'm just separating this. Numerator with denominator. I'm separating the two terms. So same formula will look like this. Therefore, E equivalent upon R equivalent is E1 R2 upon R1 R2 plus E2 R1 upon R1 R2. R1 R1 cancel, R2 R2 cancel. So this is nothing but E1 upon R1 plus E2 upon R2 is E equivalent, or you can upon R equivalent. So E equivalent will be E1 upon R1 plus E2 upon R2 upon R equivalent. So EMF you can find, equivalent resistance you can find when they are in parallel. For n resist batteries in parallel. For n cells in parallel, E equivalent will be E1 upon R1 plus E2 upon R2 up to En upon Rn upon R equivalent. R equivalent means effective resistance in parallel, which is nothing but 1 upon R plus 1 upon R2, or you can write R equivalent one and the same. And R equivalent, 1 upon R equivalent is 1 upon R1 plus 1 upon R2 dot dot dot, because they are in parallel, right? Right, this way. R equivalent will go up. So only write this much. Then I'm giving you two sums, you will get idea of parallel combination. Done? Okay. Then write advantages of cells in parallel. Advantages of cells in parallel. See, if this is one cell, this is another cell, all are in parallel. एक भी खराब हो गया तो फर्क नहीं पड़ेगा ना, because these two are still working. So parallel advantages, if even one cell is open, rest all are closed, it will keep on working. Open means wire का connection break हो गया, so still the circuit will work. So first advantage, for cells connected in parallel, or cells connected in parallel in a circuit, the circuit will for cells connected in parallel in a circuit, the circuit will not break, open, even if a cell gets damaged. For cells connected in parallel in a circuit, circuit will not break open even if a cell gets damaged. Disadvantages of cells in parallel. कितना बेल मारते हैं आप लोग? 10-10 बेल, 10-10 बेल मारते हैं? हाँ भाई साहब, 10-10 बेल मारते हैं आप लोग? कम से कम 6 बेल मारा आपने, 3 पहले मारा, 3-4 बाद में, तो 1-2 बार के रुक जाना चाहिए ना। आदमी अंदर एजेड है क्या, कैसा है? हाँ, क्या चीज है? नहीं, कुरियर मतलब कोई तो अमेजोन का है कि किसका है? हाँ, डीटीडीसी है, तो भी कम से कम 2 बेल मार के थोड़ा तो रुकना चाहिए ना, कंटिन्यूस फटाफट फटाफट बेल। नहीं नहीं, कम से कम 6 बार वाला है। अगर आदमी बीमार है अंदर, इसको अटैक बेटा कैसा समझता समझता, तो आप 2 बार मार के रुक जाते ना। ठीक है, next study, disadvantages of cells in parallel. Hello, hello, hello.
Yes, sir.
In series, voltage will be increased or decreased if we are connecting plus minus plus minus plus minus together?
So increase.
It is increasing. Okay, अभी ये सोचो, ध्यान से देखना, इधर एक सेल कनेक्ट किया मैंने, this is one cell, one internal resistance between point A and B. Between same point I connect one to this much resistance. Now tell me, terminal voltage, ये एक ही point है ना, AB. So terminal voltage across this and across this, are they same or different?
So same, no?
Same, because it is in parallel. That means when I connect two cell or I connect single cell, I cannot increase the voltage between 2 points in parallel. तो ये डिसएडवांटेज है उसका. बट सीरीज में ऐसा एक और इधर 2 कर दो तो इसका वोल्टेज ज्यादा हो जाता है ना.
Yes, sir.
Yes, sir.
ओके, राइट. डिसएडवांटेज, the voltage developed, the voltage developed, see we are not talking about EMF, we are talking about voltage at its end. The voltage developed by the cells in parallel, voltage developed by the cells in parallel connection, voltage developed by the cells in parallel connection cannot be increased, cannot be increased by increasing number of cells, number of cells present in the circuit, number of cells present in the circuit, number of cells present in the circuit. E1 equals to 6 volt, R1 is 1 ohm, E2 is 3 volt, and R2 is 1 ohm. Find E equivalent and R equivalent. Just draw this diagram. Diagram you have drawn?
Yes, sir.
अभी एक मिनट सॉल्यूशन करने के पहले एक स्टेप. We got E equivalent upon R equivalent as E1 upon R1 plus E2 upon R2. So without R equivalent I cannot get E equivalent. R equivalent means देखो ये 1 upon R equivalent है ना, ऐसा लिया तो करेक्ट.
Yes, sir.
What is 1 upon R in parallel? This will become 1 upon R1 plus 1 upon R2 बराबर ना,
Yes, sir.
equals to this E1 upon R1 plus E2 upon R2. So E equivalent is E1 upon R1 plus E2 upon R2 upon 1 upon R1 plus 1 upon R2. I will be using this formula every time to make the calculation. Otherwise, if not given, find R equivalent. बार बार मुझे ये निकालना पड़ेगा. Are you getting me what I did?
Yes, sir.
So in parallel, R E equivalent can be written as E1 upon R1 plus E2 upon R2 divided by 1 upon R1 plus 1 upon R2. What is E1? Is it 6? R1 1, E2 is 3, R2 is 1 upon 1 by 1 plus 1 by 1. 6 plus 3, 9 upon 1, 1 by 1 plus 1 by 1 is 2 by 1. So 9 by 2, 4.5 volt. Followed?
Yes, sir.
And R equivalent will be product upon sum because there are only two resistance in parallel. 1 into 1 upon 1 plus 1 equals to 1 by 2. Everybody has followed this, finding equivalent EMF and resistance? Hello?
Yes, sir.
Yes,
Now,
sir.
in case ये ऐसा उल्टा रहता ना, उल्टा मतलब प्लस के साथ माइनस कनेक्टेड, तो इधर आपको माइनस लिखना है. This is the only change. That means if like terminals are not connected together in parallel, then plus will become minus. चलो करो एक तो सब वैसा भी दूंगा बाद में. Can I clear this now?
Yes, sir.
Now first all textbook numerical I am doing. Last class we did from color find what is value of resistance. Now I'm going ulta. This is all textual sum and then we'll do MCQ. Find the color code of the following. Color code of the following. Having tolerance plus or minus 10%. First one 330 ohm. We want its color code. Tolerance is given 10%. 330 ohm. Can I write 33 into 10 raised to 1?
Yes.
Yes,
3,
sir.
3 stands for which color? BB Roy.
Orange.
BB Roy. Yes, orange, correct. So black, brown, red, orange. 0, 1, 2, 3. Orange. Next is also orange. 1 stands for brown. So what will be the color? Orange, comma orange, comma brown. Last one is silver because tolerance is 5. Clear? Everybody has followed first one?
Yes, sir.
Yeah, please copy because mostly they will ask one either color code or from value the color. Next one, see. One hundred ohm. 100 ohm can be written as 10 into 10 raised to 1. Correct? Huh? Hello?
Yes, sir.
So always first two digit and next should be multiplier. Now tell me what is 101 corresponding to? One is brown,
Yes, sir.
black, brown. And because tolerance is plus or minus 10%, so therefore it will be silver. So we got color as brown, black, brown, silver. 47 kilo ohm you will try. $47 kilo ohm वाला part try. $47 kilo ohm. What color? What color you are getting?
Yellow, violet, orange, silver.
Yellow, violet, orange, and silver. Correct. Try 160 wala. 160 ohm. Correct. Brown, blue, brown, silver.
Yes, sir.
Okay. And 1 kilo ohm. 1 kilo ohm means 1000 ohm. Hello.
Yes, sir.
Yes, sir.
So can I say this is 10 into 10 raised to 2 ohm?
Yes, sir.
Now it becomes easy. 1 corresponds to color brown, 0 corresponds to black, and 2 corresponds to red. And plus or minus 10% means silver. So we get brown, black, red, silver. If you complete, tell the next question I'm giving. Yes, done I think. Done.
Yes, sir.
Next question, right? A current 4 ampere flows through an automobile headlight. How many electrons flow through the headlight in a time 2 hours? Current of 4 ampere flows through headlight. How many electrons? And we have to find number of electron. Time is 2 hours. 2 hour means 2 into 3600 second. Current I is defined as rate of flow of charge. Charge is due to n electrons, so Ne upon time. Therefore, n is I into T upon E. I means 4. Time is given 2 into 3600 seconds. Charge of 1 electron is 1.6 into 10 raised to minus 19. 4 2s are 8 into 36 into 10 raised to 2. 16 into 10 raised to minus 20. This much you all have followed?
Yes, sir.
Yeah, please copy. Then I'm creating the space for further solution. Four into 2, 4 into 4, 4 into 9. So it is 2 into 9 into 10 raised to 22. 18 into 10 raised to 22 electrons. Next sum. The heating element connected to 230 volt draws a current of 5 ampere. Determine the amount of heat dissipated in 1 hour. take J as 4.2 joule per calorie. Heating element is connected to voltage of 230 volt, draws current of 5 ampere, find heat developed or dissipated in 1 hour, that means 3600 seconds. By Joule's law of heating, heat is VIT in joules, correct? Hello?
Yes, sir.
If you divide by J, it becomes calorie, na?
Yes, sir.
Okay, please copy till this, then we are completing further. Written full? V is 230, I is 5 ampere, time is 3600. I am dividing with 4.2. This will become in calorie. So whenever you divide with that mechanical equivalent of heat, that is J, then it becomes in heat unit calorie. Otherwise, it will remain in energy unit. This is 5 into 0, 5 into 3, 15, 5 into 2, 10, 11, into 3600 upon 4.2. By 4 we can cancel, no, by 2 we can cancel. 1800 upon 2.1. 5167, no. 619, no. So this has to be divided with calci or with log if you are knowing. 18 into 5 is 90. 80 into 5, 90, carry 9. 18 and 9, 27, carry 2. 18 and 2 is 20 into 10 raised to 3 upon 2.1 calorie. Or you can write H equals to 2070 upon 2.1 kilocalorie. 2070 upon 2.1, I am checking by calculator. 2070 divided by 2.1 is 985.71 kilocalorie. Copy this. Okay, completed.
Yes, sir.
Next sum. What is the resistance of one of the rails of a railway track? What is resistance of one of the rail of railway track 20 kilometer long at 20 degrees Celsius? The cross section area of rail is 25 centimeter square and rail is made up of steel having resistivity at 20 degrees Celsius as 6 into 10 raised to minus 8 ohm meter. 6 into 10 raised to minus 8 ohm meter. That means if this is one railway track, 20 kilometer, this is its area and specific resistance given, we want R. Can I clear this again? What is resistance means R we have to find. Length is given 20 kilometer, which is 20 into 10 raised to 3 meter. What is the area given? Area of cross section?
25 centimeter.
25.
Yes, sir.
25 centimeter square. That means 25 into 10 raised to minus 4 meter square. What is specific resistance rho given?
6 into 10 raised to minus 8 ohm meter.
Minus 8 ohm meter. Formula for resistance is rho L by A. Rho is 6 into 10 raised to minus 8. Length is 2 into 10 raised to 4. Area is 25 into 10 raised to minus 4. So 12 into 10 raised to minus 8 minus 4 upon 25 into 10 raised to minus 4. This will get cancelled. So it is equals to 12 into 0.1 upon 25 will be 0.04. So 0.480. Okay. Hello.
Yes, sir.
Yes, sir.
Clear. Doubt. Solve. Completed full? The last line?
Yes, sir.
Chalo, that's all for today. Friday test on current electricity theory, numerical, and just easy MCQs. Saturday we'll complete this full chapter and then start with MCQ.